Alright, welcome to our first inverted classroom, where this video is going to tell us how to teach you each section. We're going to do the first section here. This is section 6.1, quadratic functions. Now, most of the quadratic functions that you will see in this section will more than likely be parabolas. And graphs will look like parabolas. You will be graphing on graph paper. For in this case, since our graph paper doesn't look well on the video, we're just going to use white paper for now, but you guys will be using graph paper. Our form of the function, of the quadratic function, is in the form of ax squared plus bx plus c, where a does not equal 0. Because if a is equal to 0, we have a linear function, and we don't want a linear function at this point. So some of the things you need to know when graphing is we need to find the y-intercept. That's an important one. Much like linear equations, we are going to find the y-intercept. Intercept, there we go. Where, of course, y is equal to 0. The next thing we're going to look for is going to look for the axis of symmetry. Now the axis of symmetry, because this is a parabola, will have a point where it mirrors the graph on both sides. Let's take, for example, we have a graph. This is our parabola. There will always be like this imaginary line where if you fold it in half, you will get the exact same graph lined up on top of each other. Now that's our axis of symmetry. Now in the book they give us the equation for the axis of symmetry to be x is equal to negative b over 2a. Now we will be using this for our next one to find the vertex. Now to find the vertex, we first have to use our axis of symmetry, finding x. Once we find that, then we can find y. And we can find y on our graph, where the vertex is going to be x comma y. Alright, so with using all these strategies here, let us consider the first equation. Let us consider this function right here. We have a function. This is our first example. There we go. Now that everyone can see, this is our first example right here. We're going to consider as 2x squared plus 8x plus 9. So we know that the first term is a, the second coefficient will be b, and of course the third coefficient will be c. Now let's take a look at our first thing that we have to look for. Remember from our previous part of things to know when we're graphing, we first have to try and find the y-intercept. So when x is equal to 0, y is going to equal to 2 times 0 squared plus 8 times 0 plus 9. which this in turn gives us y is equal to 9. So there's our first part. My y-intercept is going to be 0 and 9. Now, for the next part, we are going to look at our axis of symmetry. Now remember, our axis of symmetry is going to use that equation. We're going to take that equation, we're going to plug it into, we're going to take these numbers, 2, 8, and 9. Make sure you take the sign with it. They're all positive, so we don't have to worry about that. So the axis of symmetry is going to be x is equal to negative b over 2a, thus making it negative 8 over 2 times 2. That in turn will give us negative 8 over 4, which is equal to negative 2. So far so good. Now the last part, we're going to try and find our vertex. So since our axis of symmetry, I'm going to shorthand symmetry, axis of symmetry is x is equal to 2, or negative 2, thank you. Then that means we are going to plug it in. Y is equal to 2 times 2 squared plus 8 times negative 2 plus 9. Y will be equal to 1. So thus our vertex will equal negative 2 comma 1. Alright, now we can graph. Now we can graph part of it. We're almost done because we do need to make one point, because since this is a parabola, we are going to try and determine one more point. Now, when you're looking for the points, make sure that you're taking one on each side of the axis of symmetry. Your y-intercept will be on one side of the axis of symmetry, where then you're going to have to find the second one. So let's move this up a little bit higher, and let's take a look at some of the things we can do. Let's take our graph for now. Let's take our graph for now. The first thing we're going to do is we're going to plug in our y-intercept, which is 0 and 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is our first one, 0 and 9. Our next one is going to be the axis of symmetry, or the vertex, which is negative 2 and 1, which is right here. Now we know the axis of symmetry is going straight down. There's an imaginary line going straight down, so we are going to mirror it, of course. So what we're going to do is we're going to take a number on the left side of the graph. We're going to try and use 3. So let's see what happens when we use 3. So when x is equal to 3, this is our third point, one more point. Alright, so let us try and graph that. Y is equal to 2, negative 3 squared plus 8 times negative 3 plus 9. Now if we plug that into the calculator, if we're going to plug that into the calculator, we get, let's see, so we will get over here, this is going to give us 18 plus a negative 24 plus 9. So 18 minus 24 plus 9, that will give us 3. So from here we're going to go up 3, 1, 2, 3, at 3, at negative 3, I'm sorry, when x is negative 3, 3. Thus my graph will look like this. Okay, So now we are looking for max and min. So we are going to take a look at the function again. Ax squared plus bx plus c. So when we look at this, the coefficient a will help us determine the max or the minimum. Alright, we have two scenarios. If a is greater than 0, or in this case, if a is positive, the graph goes up. And it has a minimum. If I draw my model, you'll see that when it means goes upward, this maximum, that's my minimum, the vertex. Now you have to remember, it is not the vertex of x, it is the vertex of what is the value of y. Whatever the y is, you have to remember that it is going to be the value of y. So the next scenario is if a is less than 0, which means that the value is negative. Then the graph goes downward and has a max. So if we look at the model of the graph again, the maximum, which is over here, is my vertex, which is again my y value. Now remember, this is what we're looking for. Max when it's less than, minimum when it's greater than 0. When you have a positive, you're looking for the minimum. When you have a negative, you're looking for the maximum. Those are the same cases, so just remember your note for max and min. For max and min, you are looking for the values of y at the vertex.